What up, vlog? Kayla ain't here. I know you about to cry, but your boy took
You know what
over.
I'm saying?
Okay. So 8.5 talks about arc lengths and areas, finding arc lengths and areas. Okay. What? Yes. In that blue bag behind my desk, there's like a plastic bag of things. Okay. Okay, so I kind of talked to you about this a little bit the other day. That blue bag, there's a plastic bag in there with Band-Aids. I kind of talked to you the other day about how when we inscribe a shape in a circle, we can divide it into triangles, and if we use the central angle, because we know a circle is 360, and we know how many sides are in that shape, we can figure out what the central angle is, yeah? Okay, so we're going to talk about stuff relating to that a little bit. We'll get more into it later on, but right now we're going to talk about some stuff. Okay, an arc length and an area, okay? A circle's perimeter is the circumference, right? How do we find circumference? Yeah, C equals 2D or 2 pi r, right? I mean, equals pi d or 2 pi r, okay? So circumference equals 2 pi r or pi d, okay? Either works. So the outside of my circle is my circumference, okay? We're going to focus on this version of the formula today because it's going to make it easier for what we need to do. Okay? Circumference and arc length are defined a little bit different. So circumference is how far we travel around the circle, right? Okay? Now we're going to talk about arc length. What we've been doing is our arc, the measure of our arc, which is a degree. A length, though, isn't a degree. It's a unit of measure like inches, centimeters, whatever. Okay? So all circles have an arc length or have a length to them. The circumference is their length, right? Okay? But we can divide those into sectors. Like if I created an angle with this, here I have a arc length. Okay? I'm taking a portion of that away. We're going to talk about how do you find a portion of your arc, like the arc length. How do I find a portion of that whole circle? Okay? So you're going to set up proportion. Okay? You're going to do your arc length over top of 2 pi r. Why would I put it over top of 2 pi r? Because it's, okay, if I'm finding an arc length, I'm figuring out the measure of this portion right here as in the centimeters or however many distance it takes, right? My circumference is a distance around a circle. So I'm saying I want a portion of that distance, okay? And I'm going to set it equal to the central angle over 360 degrees, okay? Because if I know that a circle is 360 degrees, and if I can know either the arc length or the central angle, I can solve the other, okay? So arc length, if I rearrange the problem, okay, I can set up this proportion. But if I'm just trying to solve for arc length, right, I would rearrange this problem to say central angle over 360 times 2 pi r, right? Because that's how I get rid of this, is to multiply it to the other side, okay? So I just rearranged it. You don't have to rearrange it. You can cross multiply and solve. You can do whatever you want that way. It's just, that's a way to rearrange it if you want. So if you have a circle, okay, and I have a portion of it like this, okay, and I know that this is 6 feet, and I know that this is 49 degrees, okay, This S, when they're looking for S like that, when they have an S, that means they want to know what the arc length is. What?
Can I go get your water?
Yeah. So how can I set this up to figure out what the arc length is? Kayla?
You put an X in for arc length, 'cause we don't know that, or an S,
Yeah.
and then do 12 times pi, because 6 times 2 is 12.
Okay, so you want to do, okay, I'm going to just write it all the way out. So I'm going to say 2 pi 6, like that, right?
Yeah.
Okay, and then what goes in here?
The 49 degrees on the top and then 360.
And then 360 on the bottom, okay? So I'm going to multiply those together and solve. So if I do 49, I don't know what 49 over 360 is off the top of my head. So I'm gonna just do 49 divided by 360. I get 0.136. I'm just gonna round it to that. So my thing equals, and then I have 12 pi, right? So I'm gonna take 12 pi and times it by that. And you should get an answer, round it to 2 decimals. What do you get? What do you get when you round that to 2 decimals?
Sure.
What?
And you want a decimal?
Yeah, round it to 2.
I got 5.12.
Okay, yeah, I get 5.13, same. And this is in feet. Make sure you put your unit of measure with it or you will get it wrong. Okay? So when I'm finding an arc length, that's the formula I use. Now, they use this a lot when you're dealing with a track, you know, a running track, how they're shaped like this. They have a straightaway, right? A straightaway, and they have curves here.
Mm-hmm.
Yeah? They'll use this a lot to figure out what the length of a track is. Because I can measure a straightaway very easy, yes?
Mm-hmm.
What happens when I create this curve? What do I actually create? If it was drawn perfectly, what would you create? A what? Well, this is a rectangle, but what do these curved parts create right here? Yeah, arcs. And so they're gonna create like half circles, okay? On arcs. So they'll use this formula to figure out the length of that arc, okay? So that they can make sure that the track is always the right amount. Does that make sense? Okay. The other thing we need to talk about is finding the area of a section of a circle, okay? The area of what's called a sector. Okay, the area of a sector. Once again, I'm setting up proportions, okay? Similar to the relationship between circumference and arc length. The area of a circle and the area of a sector also share proportionality, okay? A sector of a circle is a region defined by 2 radii that and the arc that they intersect. So if I am looking at a sector, what I'm talking about finding is this. If I have a circle and I have this, and I want to figure out what the area of this portion of my circle is, okay? Like if you have a pie and you take a piece of pie away and I want to figure out how much surface area of pie I have left. That's what you're doing. Does that make sense? Okay? So when you're looking for the area of a sector, you're looking for a portion that you took out or that you are doing something with. Okay? So, because of that, you are going to set up another proportion. You're going to set up a portion to find the sector area over the circle area. Now, how do we find the area of a circle? Equals, once again, the central angle over 1 revolution. Now they say 1 revolution. What is 1 revolution essentially?
1 whole.
360, thank you, Carly. It's 360 degrees.
Same thing.
Yes. Okay. Which would make sense because if I'm doing a central angle, That's a degree, so I have to have a degree over a degree, okay? Now, how do you find the area of a circle? What is the formula for area of a circle? You should know this. I don't care what you do, but you need to look it up and figure it out. You have plenty of resources in the world.
A equals pi r squared.
Yeah, equals pi r squared. Pi times my radius
I knew
squared.
that.
That was close. Okay.
I just
Pi r
added the
squared.
2 to the r.
So I already can sub things in, right? I can take the sector. This is what I actually have when I'm dealing with my equation. Right? The only thing I need is one or the other. I either need the area of the sector or I need the central angle, okay? So, if I have a circle that looks like this, then we are going to go like this. We're gonna go boom, boom. We're gonna say R equals 10. We're gonna say this is 45 degrees, and we're going to go like this. Okay. What are the areas of the sectors? Okay, because I have two sectors happening here. I have this sector and I have this other shaded sector. They want the areas of both of them. How can I set that up? What can I do?
Wait, I have a question.
Okay, what?
How would you set it, could you set the portions up like you set that one up?
Yeah, it's easy. You just take this and multiply it to the other side.
Okay.
So sector area would equal the central angle over 360 times pi r squared. Okay, so if I want to find the area of both sectors, what do I need to do? What do you want to substitute?
Which one?
10 would go in for r, yes. And 45 would go in for my central angle. So I'm going to say sector area equals, and I'm going to say 45 degrees over 360, and then I'm going to say pi times 10 squared, right? Okay, so let's do that. What do you get? What? 39.25. Okay. 39.25. Now, that's just the small sector, correct? They also want the area of the other sector. How can you figure out the area of the other sector? I can do one of two things, because it's very simple. I can do this problem again, because I know a circle is 360, and if I subtract 345 from 360, I know what the central angle of the other angle is. Or, I can figure out what the area of the whole circle is and just subtract the part that I already have. Use some common sense, yes? So how do I find the area of the whole circle? Pi r squared. So, 100 pi, right? Which gives me what? What's 100 pi? $314.16, something like that. From it, I'm going to subtract 39.25. When I subtract 39.25 from it, what do you get? 274 point what? Okay, something like that. So that's the area of both sectors. That's one, there's the other one. And I think, I don't know what it is, they're in, probably in here. Okay, so that's how you're solving some stuff. Then they take us into yeah. Then they take us into finding stuff like this. Let's see what this is. If I have a square, okay, we're gonna pretend that everything's perfect on this. And then they're gonna have like little curves, like little curved areas on this. Kind of like fan blades, you know how like fan blades look? We're gonna pretend that all of these are exactly the same, okay? And they're each 45 degrees. Okay, and this is 4 meters by 4 meters. Okay, this says for a sculpture, an artist removes 4 45-degree sectors as shown on the square. What's the remaining area on the surface you see? How can I figure that out? I need you to talk to me. I need you to give me any ideas you have.
Did you find the area of the square first?
Okay, Kayla, good. Let's find the area of the square first. So, area of a square, how do you find that? Side squared. So the area of the square equals 4 squared, which is 16 meters squared. Okay, that's my starting point. Now what do I need to find probably? You said the lengths of what they took out? Okay. Let's pretend that this, let me show you, let me try something. What happens if I do this? What if I make this reach, pretend like it's perfect, that it's reaching out to all edges, okay? So how long would these be here if they reach from the center to there? What would they be? What do you think they would be if they reach from the center out? How can I figure it out? How can I figure out what the radius of a square is? What? Well, technically I have a circle inside of here already, right? This is making a circle that's inside of here, yes? Okay, so do you know what the diameter of this is? What? So what's the radius? Yeah. So these, each of these are 2, right? Okay, so each of these are 2 here, which means I can solve this. How can I solve it now? How do I figure out the area of a sector? It's there. Okay, so the area of my sector, right, is going to equal what?
Central angle.
Okay, I want numbers.
45.
Okay, 45 degrees over what?
360.
Over 360 degrees times what?
Pi 2 squared.
Good, pi 2 squared. So what's 4? So let's figure out what that is. So I do 45, I divide by 360.
0.125.
What?
0.125.
Yep. And then I take 4 times 4 pi times that, right? So 4 pi times 0.125. What do you get? Okay, now here's the thing. Here's the thing. How many of those fan shapes do they represent? How many does this represent? How many do I have? So what do you still need to do? Multiply by 4. When I multiply by 4, what do you get? 6.28? Beautiful. 6.28. Now, I have to take this piece of information and do what with it? Okay, and the question was, how much area is left once those pieces are taken out? Subtract it from 16. 16 minus 6.28, and you get 9.72 meters squared still. Okay? It's just like we did a problem in the book, like we did an example of it.
You. That's it. I know y'all.
It's like, you're looking for what the horizon is, so the circle's here, I'm looking for this part of the horizon. Okay, so that's how, you figure that out. That is where we are going to stop, because we're not gonna talk about radians. Kayla? Your homework is already on the board. It's 1 through 3, all 11 through 29, odd 30, 41, and 42 on page 395.
Like, subscribe, comment, tweet me at David Dobrik. Anything else to add, Bryson?
Carly's like, I can work with numbers.